Hi, my name is Andrew Gaul. I'm from Bounce Storage. I'd like to introduce you to SwiftProxy and S3Proxy. It's a joint work between my collaborator Kahing Chung and I. So before we start, I'd like to describe a particular problem to you. So today, cloud applications are usually written against a single cloud provider, for example, Amazon S3. These either use the REST API or a vendor SDK to communicate to the provider. The state machine looks really simple here. The application talks the S3 protocol to the Amazon provider. So what happens when you want to move to something like OpenStack Swift? Do you rewrite your application using another REST API or a vendor SDK? So a partial solution to this is that you can use a portable multi-cloud toolkit. There are many high-quality implementations available for many different languages, Java, Ruby, Node.js, etc. And these give you source code compatibility between providers. So you can go to Amazon or Microsoft or OpenStack or Google. And the architecture for this is really simple. The application talks to something like JClouds, and that can get you access to any of those providers. So note that this requires modifying your application. So your developers actually have to go change every single cloud call site you have. So a more complete solution to this is you can use S3Proxy or SwiftProxy. And what these do is they allow you access to other object stores without rewriting your application. So all you have to do is change the endpoint and perhaps some credentials, depending how you've configured this. These provide S3 and REST front ends. Note that these are separate server processes. You don't change your Swift daemon. You don't do anything to Amazon or anything like that. These are true proxies in that sense. We use Apache JClouds to give you access to all the backends. And the architecture for this is much better than before. You have an unmodified application talking to S3Proxy, and that can talk to any provider. So this has all the features you would expect from a cloud object store proxy. It has create, delete, remove buckets, it has all the object operations, put, get, delete, list. We even support stuff like multi-part upload. You can store and retrieve user and content metadata. We support some more advanced features like server-side copy and multi-object delete. And I'd like to walk through a simple example of how this works. So imagine you have this adorable kitten that you want to upload to the cloud because it's so adorable that it needs to be shared with everyone. So when your application issues an S3 REST call, it does a HTTP put with that verb. Amazon puts the container name, let's say you named it photos, in the host header. And then the object name is in the HTTP path. So note the authentication scheme here. Amazon uses their own AWS variant. It embeds the account in the authorization header and uses a HMAC signature appended to that. So when S3Proxy intercepts this request, it'll translate this into Java code, and it'll have a blob store object that's calling the putBlob method into the photos bucket and the blob that you constructed. Apache JClouds will then, in turn, translate this request into something like Swift. And so the Swift request looks a little bit different, but similar. So it uses the same HTTP put verb. It embeds the Swift version in the path, and it puts the account in the path as well as the container name. And finally, your kitten.jpg. Note that the Swift uses its own authentication scheme, which is not compatible with Amazon, but we translate between all these things. So more exciting use of these proxies is actually not merely a protocol translation, but you can actually write middlewares. So consider if you had a S3 application talking to S3Proxy, and that's talking to Amazon. So when you have this proxy, this gives you an opportunity to implement new functionality, custom middlewares. So you could do different kinds of authentication schemes like Active Directory. You could do different kinds of compression, logging, quality service, quotas, tiering. I mean, there's really an unlimited number of possibilities here. And the best part is you don't need any changes to your application or provider to get these new features. You can really just add things it's a separation of concerns. You don't need to do any custom work for these two ends. There's several other kind of intriguing uses of S3Proxy that have come out of just use and feedback from the community. One of which is doing local testing using the file system backend. So this allows you to set up kind of a mini blob store. So it talks, for example, in your integration test, you could replace using Amazon S3, so you could avoid costs and have better cycle times. There's a couple different open source projects doing this. You can replace Swift all in one. While this thing is a great piece of software, it's actually a little onerous to set up for beginning user, so the SwiftProxy is much more streamlined. It has a single binary and it has a single configuration file. There's not a whole lot you need to do to get going. And one of the cool things is you can use the wide variety, the rich ecosystem of S3-based Fuse file systems. So while there is a one Swift-based Fuse file system, CloudFuse, it's essentially unmaintained and has a couple serious issues with it that are unresolved. So instead, you can use S3FS, which is very popular, or S3 Creole, S3 Backer, or a couple other ones that are really good, via S3Proxy, and use that with any backend like Azure or Cloud Files. Thirdly, you can substitute for the the Swift 3 middleware in OpenStack Swift. So this does a similar kind of translation at the in OpenStack itself, but most public providers, for example, Rackspace or HP Helion, don't enable it. Either they haven't validated it or because of some of the feature gaps it has. And there's really a lot of other uses that we've heard at the summit, and I encourage you to give us feedback on other things we could do with this. So looking forward, while these proxies are really high quality, there are a couple of features we have not yet implemented. So the most obvious one would be object versioning. So this is the ability to undelete things after you've deleted them to kind of go back in time. This requires some support from the underlying Apache JClouds that we haven't gotten to yet. So the second one is a little more compelling. The server-side encryption that some blob store providers give you is actually not ideal. So you encrypt the object, and you send the object to the public provider. And then you send the encryption key as well. But how do you trust this provider? Ideally, you'd like to terminate this encryption request at the S3Proxy or SwiftProxy layer, send the encrypted object to the public blob store, and then store the encryption key locally. Fourth, we'd like to support Amazon Glacier. And so this is a very challenging provider because it's optimized for capacity and not for access. So you get a good discount on storing things at rest, but when you want to retrieve things, they require 4 to 5 hours of latency to get a single object. So we have some ideas on how to bring this into S3Proxy and allow some applications to access it without rewriting their application. Moving forward, we actually want to improve our test coverage. We currently use Ceph S3 tests and the Swift integration tests, and we're active pushing back to the former. But there's still some gaps in the system that we can fill, minor kind of details that are uncodable characters and stuff like that. But we want to bridge those to give the best possible fidelity to users of S3Proxy. Just to summarize, S3Proxy and SwiftProxy offer protocol translation and allow you to write custom middlewares. These are both Apache licensed free software and Java implementations, and they're available on GitHub at bouncestorage/S3Proxy or SwiftProxy. Thank you for your time.